Okay, so here's this thing sliding along, and we want to figure out the time it takes for this guy to stop. Um, and so I think it's sliding, so I think we're going to use this coefficient here. Right, so the step one is I'm going to find that, right? The force of friction is mu times a normal force, which is mu times m times g, right? So that's going to be 0.48 times 22 times 9.81. This is kilograms, that's newtons per kilogram. So 0.48 times 22 times 9.81. This is 103.5936. Right? And then basically you've got this thing sliding along. You've got the force of gravity, which is down, right? You've got an equal and opposite force up. This is the normal force. This is gravity, right? This is going to be roughly 220 newtons, and 220 newtons roughly up, right? Okay. And as it slides to the right, the only force acting horizontally is this 103 newtons. That should be much shorter than these, but there it is, right? You've got negative 103.5936 newtons. And people find this very, how can it slide to the right? Well, its inertia is going to make it slide to the right. It's got momentum. It's going to slide to the right, apparently some distance here, right? And we want to know how much time it takes to stop, right? So let's figure out the acceleration. In the horizontal direction, the forces acting on it, I'm using F equals ma. Right, the forces acting on it are, well, only that force, right? So negative 103.5936 newtons equals 22 times A, right? That's kilograms. So now we're all set. I'm going to take that and divide by 22. And I get that the acceleration is negative 4.7088. Okay, and now the question is how much time does it take? That's going to be a SUVOT, isn't it? Right? So we got to do a little thing here, right? So SUV A and T, right? The initial velocity is 12, the final velocity is 0. The acceleration is negative 4.7088, and that's meters per second squared, right? And then I would use V equals U plus AT for that. And I think we get 12 divided by that answer. It's basically 12 divided by 4.7. I get 2.548 seconds. Equals 2.548 seconds. So then the question is, why did I write 2.6? It's actually 2.5, isn't it? Ta-da!